Someone from the group? Okay, anyone from the group? Agnino, Nusaiba, Putri Ayu Lestari, Ramadhani, Danti, yeah? And Rosa. Either one of you can just go through the answer for the second question. Anyone from the first group? Anyone? Come on, guys, quickly. Don't waste time. We have a lot to finish today. Come, any of the group member? I have your names here. You better present, right? Agnino, Nusaiba, Putri. Can you all hear me? Can you all hear me?
Yes, Doctor. I'm sorry, Doctor.
Yeah, so can you, yeah, Kevin, right? Yeah, Agnino, Kevin. Can you present?
I'll try I'll try, Doctor.
It's okay. If it's wrong, never mind. If you want to use Bahasa, it's okay also. Okay. Just go ahead. I'll help you to share the screen.
I'm sorry, Doctor. I don't have the file. So
oh, it's okay. I'm sharing now. You can see, right? This is your answer. So you can just, you know, present from this. I already helped you to share.
Doctor, can you scroll
Yes.
presentation?
Sorry?
Scroll down.
Scroll down.
Can you scroll down? Yes.
Yeah, sure.
Thank you, Doctor. So, the question number 1, the rate of reaction at
You are muted, yeah? Ramadanti. Your microphone is muted.
can I speak bahasa, Dokter?
Can, sure.
Oke, jadi teman-teman, di pertanyaan nomor 1 ini kan ditanyakan mengenai laju reaksi saat T-nya itu di 100 gitu ya. Dan kita menemukan tangan dari grafik ini senilai 0,006 dengan X value-nya itu adalah 100 second dan Y value-nya itu adalah 0,6856. Jadi kami mendapatkan hasil tangannya itu adalah 0,006 atau 0,007. Seperti itu. Kemudian di poin B, the question about rate of reaction at 450 menit gitu ya, teman-teman. And our group find the tangan value is 4 4,467 kali 10 pangkat min 4 dengan X value-nya adalah 450 second dan Y value-nya adalah 0,2 gitu. Kemudian ditanyakan mengenai order of reaction berdasarkan grafik dengan T1 atau T2-nya adalah 300 second. Kemudian kami mendapatkan order pertama dengan rumus seperti yang sudah terlihat oleh teman-teman gitu ya. Scroll down please, thank you. Dan kami mendapatkan nilai sebesar 0,0227 per second gitu. Kemudian untuk poin B, Agnino, can you help me?
For the question for the question B, how will the rate constant change if the reaction is carried at higher temperature? It's because increased temperature will also increase the number of collisions between molecules per unit time, because the velocity of the particle is proportional to the square root of its kinetic energy. Maybe it's all, Doctor.
Okay, thank you. Thank you, Group 1. So I find that all of you actually give very similar answers, right? Now, but I would like to point out, because there's a few mistakes, okay, in all the groups, right? So, but never mind. So let me show you what are the mistakes, okay? All right. Now, if you look at the first part, okay, the first part of the question, requires you to plot the suitable graph. Okay, so this is okay. So in order to plot the graph, you can either use what they call your Graphical, or you want to use your Excel. That is fine. Okay, so what happened here is you have to remember, okay, what you have learned before we learn about your integrals, right? Remember, we learned about the different types of rates and how to find them, okay? So if you look back at your notes, you would know that this question actually asks you for the instantaneous rate, all right? Okay, so it is asking for that particular point, right? And you draw a tangent. So if you are using your, what do you call, Graphical, okay, when you draw the tangent, you just click and then you draw the tangent to the point that you want. Okay, it actually already give you the values. All right. So here, okay, you can see the slope here. Okay, the slope here. Okay, that is your R. The instantaneous rate at 100 minutes. Okay, you don't have to do this. You don't have to do this. Okay, they already give you. Okay, so if you use Graphical, remember, you can just read straight from the graph. Okay, at that particular point. So at 100 minutes, okay, 100 minutes. Okay, at 100 minutes, that is the value. Okay, this value. Okay, so the same goes for the next one. All right. Let me just clear everything. Okay, so the same goes to here. So this is the value of rate at 450. Okay. All right. So remember this. Okay, you can always check back your notes, right? The earlier weeks. Okay, if you look at it, right? So you have to remember that you have to remember all the different methods that you have learned so far. Okay. All right. So this question is actually basically asking you to remember back what you learned a few weeks back, right? So you don't have to do this, right? Okay, now for the next part, order of reaction. All right, now here your method is correct. Okay, method is correct, but why this value? Okay, here it is 1.0, correct? Okay, so we learn in your half-life, it should be CO over 2. Okay, so it must be 1.0 over 2, okay, which is equals to 0.5, correct? So it should be here, 0.5. Am I not right? Okay, so your line should be here. Okay, so this is about 180, 190. Okay, so from here, so now you have CO2. Okay, so you divide another 2. Okay, so from here, which means 0.5 divided by 2. So equals to 0.25. Right? So now it is somewhere. So this is 0.4, this is 0.2. So 0.25 is somewhere around here. Okay, so 0.25. Then you have to draw another line here. Okay, and then I think you will get from here to here is about 180, and then here to here, I think you will get about 190. Okay, so it is T1 almost the same as T2. Okay, all right. So you can, this one is correct, first order. But I'm not sure why you guys got 300. Okay, I don't know why you chose this point and this point. Okay, all of you did the same. So I don't know whether you guys copy each other or what, I'm not sure. Okay, but remember this is 1.0. Okay, so you must divide by 2. So it is 0.5. Okay, all right. All right, so that one is for the order of reaction. Now for the rate constant, so of course now you have to use your, what do you call, your T half. So now from here, you know that your T half is 190 plus 180, because it's, you need to get the average, because there is slight difference. So you need to get the average. Okay, so calculate here. 190 plus 180 divided by 2 is about 185. Okay, so 185 is your T half. All right, so your rate constant K is 0.6. Ln 2 is 693, right? Ln 2, yeah, 693 divided by 185. Okay, so by 185. So the answer that you get is 3.75 times by 10 power of negative 3. Okay, so this is the answer. Right? Okay, so please take note on the mistakes, because all the groups actually made the same mistake. Right? Okay. Right. Okay, so but B is correct. Okay, you increase the temperature, so it increases. Right? So remember, refer back to your old notes, right? And then see how we determine your rate from your graph, okay, at a certain point. Okay, right. That is for your, what do you call, your question that was given last week. Okay, so now we will go into today's lesson, which is a continuation of last week's lecture. Okay, let me just share it with you. Okay, you can see that. Right. Okay. So today we will continue from last week. Okay. Last week we were looking at first order reaction, the integral, and also the half-life. Okay, from the first order reaction. Okay. So today we will go into the second order reaction. Okay. So of course you must know how to write the rate law. Okay. Then you have your rate constant. Then your A is for your species. Okay. Power of 2. Right. So assuming that it's a second order reaction with respect to A. Right. Or you can also write it as dc over dt. Okay, negative dc over dt equals to k c power of 2, where c is the concentration of A at time t. Okay, so you will find that sometimes we can use C and sometimes we'll be using A. So C is actually basically saying the concentration, and A is referring to the species itself. All right, so that's why you have to put the concentration bracket. Okay, all right. So now you can integrate this this equation. Okay, dA over A power of 2. All right, equals to k from t equals to 0 to t. All right, okay, dt. Right. So when you integrate this equation, okay, so when you integrate the equation, just give me one moment. Okay, just give me one moment. So when you integrate the equation, you will get that it is 1 A power of -2. So it is 1 over A. All right. So if you check back in your notes, I think there's a typo here. I think in your notes it's written as A -1 over A. Okay. So this is wrong. Okay. Please make the necessary changes. It should be 1 over concentration of A. All right. Then once you integrate it from AO to A, all right, and then you get equals to KT, all right. So when you solve this equation, all right, so it will become -1 over A, right, and you minus with, okay, minus with 1 over AO, okay. So when you solve this, then you can rearrange in order to get this particular equation. All right. Okay. And you rearrange so that it follows your y equals to mx plus c. Okay. So when you rearrange this equation, your 1 over a becomes your y. Okay. Your m, which is the slope, becomes your k. Right. And your t becomes your x value. And your 1 over AO becomes your, what do you call, your intercept. Okay, so your intercepts here is 1 over AO. Okay, and your slope is K. All right, your slope is K. All right, so how do you find slope? You draw a triangle. Okay, or if you use your, what do you call, Graphmatica, you can get the equation for your graph from the Graphmatica, so you don't have to calculate. All right. So where AO is the concentration at time t equals to 0, right? And A is the concentration at time t. So when you plot a graph of 1 over A against t, you'll get a straight line with a positive gradient. So you must remember for a second order reaction, okay, the two things that you need to remember is this, right? Okay, this and the graph. Okay, how does the graph looks? Okay, and what are the information that you can get from your graph? Is 1 over AO for the intercept and also your slope. Okay, so this is the information you can get from your integral of your second order. Okay, now let's look at one question in order for you to know. how the graph will look like and how are you going to calculate it. Okay, so this is again a very simple example. All right, so you got time per second. Okay, and then you have your x concentration, mole per dm cube. And the question asks you to plot a graph of 1 over x against time. Okay, and use it to determine the rate constant for the reaction. Okay, so at time 0, 0.1, 100, 200, 300, 400, 600, you can either plot it again using your Excel, or you can plot using your Graphical. All right, so let's say you use your Excel, all right, then you must remember you want to plot 1 over x. Okay, so first you need to convert all of these values to 1 over x. Okay, once you have converted to 1 over x, then you plot 1 over x over time. Okay, so then you get your straight line, and now you want to determine the rate constant for the reaction. Okay, so when you plot 1 over x over time and you get a straight line with a positive slope where your k is positive, so you know this is reaction is a second order with respect to x. Okay, so you can write this out. Okay, so remember last week the first order reaction, the equation. So this week we are learning the last week we learned the first order reaction, the integral equation, as well as the half-life equation for first order. Okay, and the rules for your half-life for first order. So this week we are learning the second order integral, okay, which is this, right? You have to remember 1 over c equals to kt plus 1 over c naught. Okay, this is second order with respect to x, all right? And the gradient of the graph is, okay, so you draw a triangle to your line, right? And then you find the difference between here and here, okay? So it is 30 minus 10, correct? Because here if you see, so here is 30, okay, and here is 10, correct? All right, so it's 30 minus 10 equals to 20, all right? So here, for the y value, it is 500, okay? So it is 20 over 500, and you will get your gradient of the graph, which is your slope or your rate constant. Okay, so that's how you find your rate constant. So please remember that, yeah, okay? Okay, now moving on, okay, moving on to the half-life of your second order reaction, right? So when T, remember back what is your half-life, okay, where the concentration goes to half of its original value, the time when the concentration of your species goes to half of its original value. Please remember the definition, yeah? Right? So when your T becomes T half and C is equals to CO2, right? So now you substitute into your, this is your original second order integral equation, right? So now you put in, right, your concentration is C over 2, all right? C naught over 2. C naught is the initial concentration, okay? That's what it means for half-life, okay? Half of the initial concentration. So C naught over 2 equals to K constant, your T becomes T half, okay? The time taken for the initial concentration to drop to half of its value. Okay, so KT half plus 1 over C naught. C naught is your original initial concentration. Okay, so from here, you rearrange and you solve this equation, you will get T half equals to 1 over constant C naught. Okay, okay, all right. All right. So when you plot the graph of C, this is not C naught, yeah? This is C naught. Okay, the graph of C over T, right? And then you have your C naught, which is your initial concentration. right? So the time taken for it to drop to half of the original concentration, okay? So you draw one line, okay? Then you get your T1, okay? Then from here, you divide another time, divide by 2. So it's C0 over 4 now. Okay, so C0 over 4, and you get your T2 at here. Okay, so you will find that the value of T2 is 2 times T1. Okay, the value here, okay, the value here, okay, is 2 times of T1, right? So remember in the first order reaction, the half-life, okay, for first order, okay, the half-life was T1 equals to T2, remember? So now for second order, okay, second order, it is T2 equals to 2 of T1, 2 or approximately, sometimes it can be more than 2, right? Slightly more than 2, right? Okay, so now you get the second equation for your half-life, okay? So your the first order of half-life, also you have to remember ln 2 over k, right? So for second order is 1 over k C0, okay? So for your first order reaction, it is not affected by the concentration, but second order, it is dependent on the concentration. Now, another thing you have to know is the half-life of the second order reaction is inversely proportionate to the amount of substance present. Okay, so you can see here the inversely proportionate. This and this are inversely proportionate. Okay, all right. So remember that because you can use that information later to answer your question. All right. Now, let's look at another example, okay, for using your half-life, okay, in order to calculate. So this is another way your questions can be, apart from the type of question that I gave you last week on the first order half-life, where you draw the graph and then you read the values from the graph. Another way your questions can be is also here. All right, so let's look at this question. The reaction 2NO-Br, okay, decomposes into 2NO plus Br2. Now this is a second order reaction with respect to NO-Br. Okay, and they already gave you the constant as 0.810 M-1 S-1 at 10 degrees C. Now, if your initial concentration of NO-Br is equals to 7.5 times 10 power of negative 3 M, how much NO-Br will be left after a reaction time of T 10 minutes? Okay, so now we want to know after 10 minutes, what happened? Okay, so you have your initial concentration, you have your rate constant, you know it's a second order reaction, and now you are asked to determine the half-life of this reaction. Okay, all right. All right. So there's two parts to the question. How much will be left after 10 minutes? And then they ask you to calculate the half-life. Okay, so let's solve the first part of the question first. All right. Okay, so remembering back, okay, 1 over C0 equals to KT plus 1 over C. Correct? Okay, all right. So you can do the rearrangement, right? And then, sorry, 1 over C. I want to know 1 over C. No? Okay, 1 over C. Okay, so then you put in the, plug in all your values. Okay, now you want to find 1 over NO-Br at T equals to 10. Okay, at T equals to 10. So that means you want to find the value of this C at T 10. Okay, plus KT plus 1 over initial concentration NO-Br naught. Okay, so this one you don't know because this is what you are finding. Then K, the reactant constant, is already given in the question. Okay, and then times by, because now we change it to second. Okay, so you have 10 minutes here, we change it to seconds, okay, 600 seconds, and you 1 over 7.5 times 10 power of negative 3 n. Okay, so you solve the equation here, all right. Here there is a mistake, yeah, this is not. Okay, you solve to get the concentration of NOBR, the concentration of your NOBR, okay, at time equals to 10 minutes is 1.6 times 10 power of negative 3 m. Okay, so this is the answer. All right. Now, it's quite simple. All right. So the second part of the question is asking you to determine the half-life for this reaction. Okay. So we substitute the initial concentration of NOBR and the rate constant for the reaction into the equation for the half-life of a second order reaction. Okay, so for second order reaction, the half-life is T half equals to 1 over Ka concentration naught, or you can say C naught lah. All right, so now you know this value, you know this value, so you can easily find the half-life. Okay, just plug in all the information and you get 160 seconds. Okay, so this part is quite simple lah, the half-life of the reaction. Okay, now that is for your second order reaction. Okay, now let's go into your zero order reaction now. All right. Okay, let's look at the next integral, which is your zero order. So you will learn, you have learned first order, you have learned second order. Now we are going into zero order rate law for your integral integrated method lah. All right. So for integral, zero order rate law is expressed in terms of the time rate change of a concentration of your A. Okay. So negative dA over dt equals to K. All right. So you rearrange dA equals to negative K dt. Okay. Then you integrate this. Then you get A minus A naught equals to negative KT. Okay, so you can also rearrange this. Okay, you can either write it this way or you can also write it as A equals to negative KT plus A naught. Okay, you can also write it that way. Okay, so from here you know that the intercept here, okay, the intercept here is A naught. Okay. The intercept is A naught, then your slope is your K. All right. You always have to remember that. Okay. So this suggests that what do you call the plot of concentration as a function of time will produce a straight line with slope negative K. Okay, with the intercept at A naught. Okay, so you can see the graph is going down. Yeah? So this K will be negative, as seen by your what do you call your equation. Okay, mx plus c. Okay, so your y actually refers to the concentration of A, your m is negative K, your x is T, and your c is A naught. Okay, so when the graph is plotted, a linear graph must be obtained. Okay, so if you have a question and you are asked to determine if this is a what do you call zero order reaction. Okay, they say prove that this is a zero order reaction or not. So you look at your what do you call your equation. Okay, remember back your equation and you plot your graph A against time. And if you don't get this graph, so you can safely say that this is not a zero order rate constant. Okay, this is not a zero order with respect to A or whichever reactant that they are referring to. Okay, so that's one way of determining. So later on we will see that we also can use something called the graphical method. So we can also use these graphs to actually determine which order your reactions are falling in. All right, okay. So that is quite simple. for the zero order reaction. So also, we also have to look at the half-life for your zero order reaction. Okay, so now again, your concentration becomes half. Okay, your first initial concentration becomes half at T half. All right, so that means now you have to replace, all right, you replace A now becomes A naught over 2. Okay, so you put this, plug it into your equation. Okay, because just now we say for zero order is KT plus A naught. Okay, so now you plug in A naught over 2 inside here and you get this equation, right? And then you rearrange the equation, and when you solve it, you will get T half is actually depends on the initial concentration. Okay, so you get T half equals to A naught over 2K. All right, okay, so as the original concentration is decreased, the half-life of a zero order reaction will also decrease. Okay, so because this is directly proportionate, if this decreases, this also decreases. Okay, this is different from the second order where it's inversely proportionate. So inversely proportionate means one increase, one decrease. Okay, now because this is directly proportionate, so if your half-life decrease, your initial concentration decrease, your half-life also will decrease. Okay, so that is the pattern that you can actually look at to know which order your data is in, all right, or your reaction is in with respect to the species. All right, okay, so that is another information that you can actually get from your zero order half-life, okay, that you can compare with your second order. All right, but always remember the first order is independent of the concentration. Only your second order and the second order and zero order will depend on the concentration of the initial or half-life. Right? Okay, now let's do a very quick summary. All right, so later we will have some questions. So I would like you all to answer. And today the question we have to present it today itself and get the answers. So we will use a little bit extra time. So I will try to finish the lecture earlier so that we can have more time to finish up the question and discuss it. Because next week will be your test. Okay, so let me just explain a little bit about the test before I go on with the summary. Okay, so the test I will give you 4 to 5 questions. All right, to finish it within the 1.5 hours. All right, and I will provide you with the Google Drive link. Okay, and you can upload the answer into the Google Drive link. Okay, next week, during the class, right? And what will happen is the questions will be similar to all the pattern of questions that I've given you from the start of the lesson until now. So we will cover all the topics from the first until today. Okay, from the first class until today. So make sure you read all the notes so that you'll be ready for the test next week. Okay, all right. Okay. So moving on to the summary of the integrated rate law method. Okay, so I've actually summarized for you so that you can remember. So for zero order, A equals to negative KT plus A naught, right? And if you plot the graph of, okay, because you must always remember you want to plot MX plus C, yeah? Okay, so it is Y, your Y is your concentration of A, and your X is T. Okay, so when you plot the graph, you get your slope. Okay, your slope becomes negative K. Right? Okay. So if it is a first order reaction, it is ln A equals to negative KT plus ln A naught. Okay. Also another thing to remember, your intercept. Your intercept is A naught here. So here the intercept is ln A naught. Okay, all right, and your slope is also negative kt. Now again, this is also y equals to mx plus c. Okay, so your ln A is the value of y. Okay, and your negative k is your m, t is your x, and your intercept is ln A naught. All right, so remember the slope is negative k. Okay, now the second order reaction, 1 over A equals to kt plus 1 over A naught. All right, so again, y equals to mx plus c. So now the graph is 1 over A over time in second. Okay, so your intercept now is 1 over A naught. Okay, with a slope which is a positive value. Okay, now if you can remember this summary, okay, if let's say you have a what you call a data that you don't know which order is going to fall into, okay, you have the value of A. So the first thing you can do is you can just plot A against time. Okay, and you will find that if it is a zero order, you will not get a straight line. Okay, so as soon as you know that it is not a straight line, then you can actually suspect it can be either a first order or second order. Okay, and when you suspect whether it is a first order or second order, if let's say you already have the graph that you plotted earlier, okay, which is, all right, let's say you plot A over time, okay, then you get this kind of graph. So from there, you can use the half-life method. Okay, use the half-life method. All right, and you can remember if T1 equals to T2, then it is your first order reaction. Okay, and then if it is T2 equals to 2 of T1 or approximately, okay, or more than 2, slightly, sometimes it can be slightly more than 2, then you know that it is a second order reaction. Okay, so that is one way you can actually remember how to determine, what order your graph, your data is in, right, with respect to the particular species of the reactant. Okay, so now we can look at the summary of your half-life method. Okay, again also, please remember for zero order, your half-life is A naught over 2K. Okay, so that means if your concentration of your A decreases, your T half also will decrease. Okay, because they are directly proportional, right? Then you have your second order where it is independent of concentration. Okay, it is ln 2 over K. Now, sorry, that's your first order. Then for second order, you have T half equals to 1 over K A naught. Okay, now because this one is inversely proportionate, all right, it will, if you decrease your concentration, your T half will increase. Okay, all right, so remember the pattern as well as the equations, all right, and also the behavior of your concentration with respect to your half-life. Okay, all right. Now, we will look at one more question. All right, this one is more to the half-life, recognizing the pattern of your half-life. Okay, with that, which I just said, if it is a first order reaction, your concentration doesn't matter. Now, if your if it is a zero order, then if concentration increases, then your T half increases. Then for second order, if the concentration decreases, your T half will increase. Okay, so this question is also another type of question to show you how you can use this information of the pattern to answer. Okay, so based on the following concentration data as a function of time, determine the behavior of the half-life as the reaction progresses. Use this information to determine if the following reaction is zero order, first order, or second order with respect to A. Okay, and use the data to estimate the rate constant of the reaction. Okay, so you can see here, right? Now, because they already tell you early itself, you are going to be determining the half-life. So you can try to use the information from just now, where we talk about the concentration of your reactant or your species with the half-life pattern. Okay, so you can see here, right? If your original concentration is 1.2, okay, so the first, if your original concentration is 1.2, then the half-life is 0.6, okay, and in order to go to 0.6, all right, okay, in order to go to 0.6, so in order to go to 0.6, which is half of 1.2, it takes 20 seconds. Okay, so we use this information, all right, use this information. So we draw a table and then you put there 1.2. The half-life of 1.2 is 20 seconds. Okay, now we look at the second concentration. Now, if this is your initial concentration now, okay, if your initial concentration now is 0.8, if your initial now is 0.8, in order for 0.8 to drop to 0.4, it takes 40 seconds, correct? Okay, now that is your second, sorry, not 40 seconds, 30 seconds, because now we are taking it as 0.8 is your initial, all right? So it takes 30 seconds to reduce to its half-life, okay? Now you do the same for the next value, okay? Now if 0.6 is your initial value, okay, now you assume 0.6 is your initial value. So half of 0.6 is 30. So the amount of time it takes from here to here is 40 seconds, correct? The 60 minus 20, okay? For 0.6 to drop to half of its concentration, it is 40 seconds, okay? And you do the same for the next one, okay? Because right now we want to recognize the pattern, okay? So 0.4 drop to 0.2. So here it takes 60 seconds, all right? Now, if you look at this, all right, there is a pattern here that you can now already recognize, okay? As the concentration of your initial decreases for this reaction, your T half is actually increasing. Can you see that? If your initial concentration is 1.2, your T half is 20. If your initial concentration is 0.8, your T half is 30. If your initial concentration is 0.6, your T half is 40. And if your initial concentration is 0.4, your T half is 60. So from here, you can recognize the pattern. As your initial concentration decreases, your T half increases. So which, what they call half-life has this pattern? All right, so you refer back here. Which half-life have this pattern? Increasing with decreasing concentration, where the half-life increases with decreasing the initial concentration. It is your second order reaction. Okay, so you just use your second order reaction, right? So from here you can tell that this is a second order reaction, and by recognizing the pattern, and then you can use the half-life for second order reaction to calculate your constant. All right, so it is quite simple in that sense, all right? So another method, or actually we can also use it for every other graphs that we have looked at so far, right? So if you have another method, is we also call it the graphical method. You can also use the graph that you plot in order to determine what is your order of reaction with respect to the particular what do you call species. Sorry about that. Sorry, yeah. The wind is too strong. Okay, so the graph for first order, second order, and zero order are shown as below. All right, so if you have the rates, okay, the concentration over concentration, then you can have your first order reaction. If with the gradient which is positive, right? And if you can plot for second order. And then if you square your concentration, you can actually get a straight line. And then for your zero order, okay, so, and so on, right? So this is more like a summary, lah. Okay. Now comes to today's part, all right, to answer the questions, question 1 and question 2, all right. So as usual, we will break into your groups, all right, and as usual, okay, students of registered students will go into group 1 to group 5, all right, and what do you call, the other students can go into group 6 until 10. Okay, so registered student group 1 to group 5, and we will try question 1 and 2, and we will present it today. Yeah, all right. So I will come in to talk to you one by one in the group. Okay, so let's see. Not sure whether Dr. Hold on. Let's break you into groups first. Okay, Dr. Galu is not here. I will have to do the breakout rooms. So I will. Okay. So the groups are open. All right. So group 1 until 5 is for registered students. Okay. So please go into group 1 to 5 for registered students and start preparing the answer to the both questions. Okay. And the rest of the students can go into group 6 to 10. Okay.
All right, doctor. Thank you.
Thank you. Okay, so can we have group 1 to just quickly present question number 1?
All right, doctor.
Yes.
Listener, can you share screen? On the share screen, the answer. Okay, we will start, doctor. So there's a data in the corner. So we put the graph in here to find the k, and we can automatically find the k with the Excel, and we find 0.19. If we make it round, is 0.2, and we try to calculate too, like the example like doctor give before. We get 0.2 in the time is near 175, with the concentration is 40 minus 5, so we get 35 divided by 175, so we get 0.2, doctor. Yes, that's all. Thank you.
Okay, good, but don't forget your units for your constant.
Oh yes.
Excel will not give you the units, but make sure you write the units.
Okay, doctor. Thank you.
Okay, for question number 2, I think I can, what I will do is you guys can put up your answers in Padlet, all right? And then I will provide the answer in Padlet. Okay, so but because I already explained to each and every group, for question number 2, we are trying to use, maybe I just share and quickly let you know how to answer or attempt question number 2. Right? So question number 2, we actually can use 2 methods. All right, you can either use the integral method where you actually plot this graph and then you calculate out your what do you call your constant and so on, or you can actually use the half-life method. Okay, you can also use the half-life method. Okay, so in order to use the half-life method, you have to plot NH4 and CO, okay, versus time. All right, so here the value will be NH4 and CO not over 2. Okay, this value is your NH4 and CO naught. Okay, this value is NH4, okay, and CO over 4. Okay, so you read T1 and T2. Okay, and you will get T2 equals to 2T1 or approximately 2T1. All right, and so from there you know that this is a second order reaction. Okay, so once you know that it is a second order reaction, you can calculate your constant using this. All right, so but how do you know what is T half? Because this is a second order reaction and your T2 and T1 is different value, so you find the average. Okay, average T half is equals to T2 plus T1 over 2. Okay, and that will give you this value. Okay, and then you can find your constant. Okay, this CO will be your NH for NCO naught, which is 22.9, right? Yeah. So this is one way to do it. Okay, but some of you did the longer way. All right, you converted into 1 over NH4 and CO, and then you find your K from the graph. You can also do that, but you must also be familiar with using the the half-life method. Right? Okay, so sometimes question will not tell you which method to use, so you can make the decision to do it. But sometimes question will tell you specifically use your half-life method, then you must know which graph to plot. Okay, all right, so I hope it's clear. Submit your answers to Padlet, all right, and please Please study for your test next week. Okay, the different types of questions will be mixed together. So now you need to know when to use which method. Right? Okay, right? So I will see you next week for your test. Right?
All right, doctor.
Thank you, everyone.
Thank you. Okay, doctor.
Thank you, dokter.